Good day, ladies and gentlemen. Today we are going to talk about large sample hypothesis test of population proportion. So here I go. So this is a lecture on large sample hypothesis test for a population proportion. As you know, hypothesis is an educated guess about a population parameter. Here, the educated guess is about the population proportion. And we are going to test, or we are going to describe a method which will test whether our educated guess about the population proportion is within the correct ballpark. The sample proportion is given by the symbol p hat. P hat is number of sample that possesses the property. The property here is sometimes referred to as number of success. N is the sample size. What is a good example of that is number of students in the campus. Of all the students in the campus who have laptop computers, or that will be for the entire population. If you are dealing with a sample, the number of students in the sample that have who have laptop computers will be the x, or the numerator of the equation for p hat, sample proportion. Okay, remember, our goal is to establish the population proportion of students in the campus who have laptop computers. We cannot reach the entire population because it is too large and too time consuming. Instead of that, we will work with a simple random sample of size n, and we will survey those students in that sample. How many of you have laptop computers? Those who will say yes, that number may be 80 or 85, say it is 80, then 80 will be number of success, n will be the sample size 100. This p hat, or sample proportion value, will serve as the basis for testing the hypothesis about p. Large sample procedure is based on same properties of sampling distribution of p hat that were used to obtain a confidence interval for p. And that is, the probability distribution of p hat, with p hat in the horizontal axis and probability density on the vertical axis, is a bell-shaped curve, with the center of this bell-shaped distribution, where the peak is the highest or relative frequency is the highest, is the center or the mean of the distribution. Mu p hat is equal to p. Notice that p is the population proportion. And the standard deviation of the sampling distribution, or probability distribution of p hat, is given by sigma p hat, which is given as square root of p, probability of success, uh, or population proportion, multiplied by 1 minus p in the numerator, divided by n in the sample size. N is the sample size, everything under square root. So what is sigma p hat? It is the standard deviation of the sampling distribution of the p hat. Basically, it tells you how much the curve is spread around the mean or the center. Sometimes the standard deviation of the sampling distribution is called standard error. When n is large, the sampling distribution of p hat is approximately normal. So condition is n is large. Okay, and we talked about a bell-shaped distribution of p hat that is approximately normal, means bell-shaped. And we talked about the mean and the standard deviation in the previous slide. Now we are going to calculate a test statistic, or the standardized variable, and it is given by z. Just like z is a standard normal variable, and it is by how many standard deviation the sample characteristic is away from the population characteristic or population parameter. Okay, how many standard deviation? Same principle here. Z, the standard normal variable or the test statistic, is given by sample characteristic here, sample proportion, how far it is away from the hypothesized population proportion P in the null hypothesis. That's in the numerator. It's called the deviation of P hat from P, P hat minus P, or difference of P hat from P. The difference is divided by square root of P times 1 minus P divided by N. So the deviation P hat minus P is divided by standard deviation of the sampling distribution, or standard error of the sampling distribution. That means Z will tell us how many standard deviation P hat is away from the hypothesized population proportion P. If Z is positive, that means P hat is greater than P, and Z will be positive. That means it's on the right of the mean. That means uh, P hat is on the right side of, or on the greater than P by so many standard deviation. If P hat is less than P, then the standardized test variable, or standardized test statistic, sometimes called, is negative. Then P hat is so many standard deviation on the left of the mean or below the mean. And if our sample size is large, then we can assume that the standardized variable Z has a standard normal distribution when N is large. Okay. Test statistic, a value calculated using the sample data. It is the value used to make the decision between rejecting and failing to reject H0. Basically, test statistic is the standardized variable that we saw in the previous slide. It is how many standard deviation P hat is away from the hypothesized population proportion in the null hypothesis. So what is P value? After we calculated the test statistic, we will calculate a P value. P stands for probability value here, capital P. A measure of inconsistency between the hypothesized value for a population characteristic and the observed sample. It is the probability, assuming H0 is true, of obtaining a test statistic value at least as inconsistent with H0 as what was observed. The p-value is sometimes called the observed significance level. Okay, so p-value is the probability of obtaining a test statistic at least as extreme as what we obtained from our sample data, or more extreme. The introduction of artificial intelligence tools such as ChatGPT has led to concern about how students are using AI and whether it poses a threat to academic integrity. Researchers at study.com surveyed students and educators to gain insight into the use of AI in schools. The online article, Productive Teaching Tool or Innovative Cheating, states that over one-third of all educators believe ChatGPT should be banned in schools and universities. Over one-third means greater than 33%. This statement was based on survey of 100 educators, with 34 responding that they believe ChatGPT should be banned. Assuming it is reasonable to regard the sample as representative of educators, does the sample provide convincing evidence in support of the claim that more than one-third of the educators believe that ChatGPT should be banned in schools and universities? So our test hypothesis or alternate hypothesis in this case is H sub A colon P greater than one-third is 0.33, as I mentioned. And our null hypothesis is H sub 0 P is equal to one-third. What is P? Population proportion of all educators who believe ChatGPT should be met. And we have a sample, simple random sample of size 100, who's among 100 students. As you saw in the last sentence, 34 is the number of success and the number of educators who believe that AI or ChatGPT should be banned in school. So p hat value is 34 by 100. As you can realize, our goal will be to compare the p hat with the hypothesized value in the null hypothesis of p. That is, we will calculate the standardized test statistic for the p hat value which we have obtained, which is 0.34. So z is given by p hat minus 0.33 is the hypothesized value in the null hypothesis, and we will calculate the standard deviation of the sampling distribution of p hat, assuming the null hypothesis to be true. That is, the standard deviation of p hat is calculated using p equal to 0.33, which is the value in the null hypothesis. Remember from the past slide, p hat is 34 over 100 is the sample proportion of success. So in the numerator of the test statistic for z, we can put a left parenthesis in front of 0.34, which is the sample proportion. We are comparing it to the value in the null hypothesis, which is minus 0.33, then right parenthesis, then divided by the horizontal line is divided by, and we have to get the square root in the denominator that is below the horizontal line. So we press second button on the top left and excess square button, which is in the first column of keys. Second and excess square is essential so that we get the square root. Inside the square root, first is p, probability of success in the null hypothesis, which is 0.33, then left parenthesis 1 minus 0.33, then right parenthesis, then again horizontal line means divided by sample size. What is our sample size? Is 100. So divided by 100. Divided by 100. And hit enter. The test statistic in my calculation comes out to be 0.321, very similar to what they got, 0.20. Now notice in the alternate hypothesis, p is greater than. That means the two slanted lines indicating greater than meets at an edge pointing to the right in the alternate, p greater than. Since it is greater than, two slanted lines meet at an edge pointing to the right, this is a right tail test. Right tail test. That is, the test statistic will fall in the right tail of the standard normal curve. And our test statistic came out as 0.2. So what we need to find out is what is the area to the right of the test statistic under the standard normal curve. That is the probability of obtaining a test statistic at least as extreme as 0.2. So we go to the calculator, second verse, and we go to normal CDF to find the area under the standard normal curve. We are going to start our calculation from 0.2. Actually, I got 0.21. So I will start from 0.21. That will be by lower boundary. My upper boundary is a very large number on the right. So I will press 1, then second button, and then comma. Why do I do that? To get the small cap e. What does the small cap e stands for? Exponent. That means 1e. And then I'll type some numbers, which is 99. That means 1 followed by 99. 0 is my upper boundary, which is a very large number on the right. I will not change. I will keep the mean at 0 because that's a standard normal curve. The standard deviation at 1, which is the standard deviation of the standard normal curve. And go down on pest. When you are on pest, hit enter twice to get the area to the right of the test statistic, which I assume to be 0.21. And that probability value is quite high, 0.4168. What does it mean? Assuming the null hypothesis to be true, the probability of getting a test statistic at least as extreme as 0.21 is 0.4168. Okay, that's quite a bit of high probability. So since the probability value, p value, is so high, we are not going to reject the null hypothesis. Why? Think of the practical aspect of it. We got a test statistic assuming p had to be, I mean, p0 to be true as 0.33. That means quite likely this sample came from a population with a population proportion of 0.33. Therefore, that is the population proportion, that is the mean. Therefore, it is quite possible that population proportion could be 0.33. Therefore, we are not going to reject the null hypothesis, which is null hypothesis is p equal to 0.33. We are not going to reject it, and therefore we can state that we do not support the alternate hypothesis. Okay. Okay. When H0 is true, about 42% of all samples would have a sample proportion as large or larger than 0.34. Therefore, this means that a sample proportion of 0.34 is reasonably consistent with the null hypothesis. Although 0.34 is larger than the hypothesized value of p equal to 0.33, chance variation from sample to sample is a plausible or possible explanation for what was observed. So, we are not going to reject the null hypothesis, and therefore we are not going to support the alternate hypothesis, which states that p is greater than 0.33. Thus, there is not convincing evidence that the proportion of all educators who believe that ChatGPT should be banned in schools and universities is greater than 1/3. A decision to reject or to fail reject H0 from comparing the p-value to the chosen significance level alpha. These are the two rules. We reject H0 if p-value is less equal to alpha, and we fail to reject H0 p-value greater than alpha. So what is alpha? Alpha is the level of significance. And what is alpha? It is 1 minus c. Okay, so alpha is the maximum risk we take in rejecting H0 when it is true. That means we should not have rejected H0, but anyways, we made a wrong decision of rejecting H0. Usually, alpha level of significance is kept at 0.05. Alpha is the risk of making type 1 error. So, alpha is usually kept at 0.05. Remember, in the last problem, we got a p-value of 0.4168. If we had assumed alpha is 0.05, our p-value would have been greater than alpha of 0.05. Hence, our decision would be do not reject H0. And conclusion would be at alpha equal to 0.05, there is not enough evidence to support the alternate that p is greater than 0.33 in the last problem. Okay. So, this is the same problem they're doing. The statistic, no, this is a different problem. Okay. With a partner, discuss the following. Be prepared to share your insights with the class. How do you think the procedure for finding the p-value would be different if the test is a two-sided test? What is a two-sided test? Remember, in this case, null hypothesis is always equal to p equal to 0.33, for example, population proportion of success. An alternate hypothesis would be HA colon P not equal to. So equal to sign with a slanted line drawn through it means not equal to 0.33. That's a two-tail test. So after we find the test statistic, if it is on the right tail, we find the area to the right of the test statistic under the standard normal curve and multiply it by 2. Same, if we find the test statistic is in the left tail, that is, it is negative, we find the area to the left of the test statistic and multiply it by 2. Okay, just like this. Okay. Upper tail test, null hypothesis P greater than, alternate hypothesis P greater than. Like I said, two slanted lines meet at an edge pointing to the right. So that means the test statistic will fall in the right tail and the and right tail, and we will find the area to the right of the test statistic under the standard normal curve or Z curve. Left tail test, alternate hypothesis P less than hypothesized value. And in this case, p-value will be the area to the left of the test statistic under the standard normal curve. And for a two-tailed test, alternate p not equal to hypothesized value, p-value is calculated as illustrated. Depending on which tail the test statistic will fall, if it is in the right tail, we find the area to the right of the test statistic in the right tail and multiply it by 2 to get the p-value. If the test statistic falls in the left tail, we find the area to the left of the test statistic and multiply it by 2. Okay, so this is the general way we will conduct the rules or steps. First, we state the null hypothesis, p equal to a hypothesized value. Then we compare the sample proportion to the population proportion, that is the one that we guessed or made an educated guess in the null hypothesis, assuming the null hypothesis is true. So we actually calculate the deviation of the sample proportion from the hypothesized population proportion and then divide the deviation or difference by the standard error or the standard deviation of the sampling distribution of p hat, assuming hypothesized value in the null hypothesis to be true. Okay. So, and then depending on the direction of the alternate hypothesis, it will be a right tail, left tail, or a two-tailed. So for alternate P greater than population proportion, then greater than hypothesized value, then our test statistic will fall in the right tail and our p-value will be the area under the Z curve to the right of the calculated C. On the other hand, if our alternate hypothesis is p less than hypothesized value, then the p-value will be the area under the standard normal curve to the left of the test statistic. And if p not equal to hypothesized value, depending on where the test statistic will fall, if it falls in the right tail, that is Z is positive, we calculate the area to the right of the test statistic under the standard normal curve multiplied by 2. On the other hand, if the test statistic is negative, then we calculate the area to the left of the test statistic under the standard normal curve and multiply it by 2. Assumptions p hat is a sample proportion from a random sample. The sample size is large. This test can be used if n satisfies both n hypothesized value n times p. N times p should be, it is not correct there, n times p should be greater or equal to 10 and n times 1 minus p should be greater or equal to 10. So n times hypothesized value means n times p0, the value in the null hypothesis, should be greater or equal to 10 and n times 1 minus p0 should be greater or equal to 10. If the sampling is without replacement, the sample size is no more than 10% of the population size. So what are the steps? Describe the population characteristics of interest, state the null hypothesis, state the alternative hypothesis, select the significance level for the test, that is the alpha value. Remember, significance level is the maximum probability of making a type 1 error, that is to reject H0 when it is true. Display the test statistic to be used, okay, with substitution of the hypothesized value identified in step 2, that is in the null hypothesis. This is where you calculate the test statistic Z, that is, in our case, we compare the sample proportion to the hypothesized value in the null hypothesis, p hat minus p0 in the top, divided by the standard error or standard deviation of the sampling distribution, assuming p0, the value in the null hypothesis, to be true. Check to make sure the assumptions required for the test are reasonable. Calculate all quantities appearing in the test statistic and the value of the test statistic itself. Determine the p-value associated with the observed value of the test statistic. State the conclusion, which is to reject H0 if p-value is less equal to alpha and fail to reject H0 otherwise. The conclusion should then be stated in the context of the problem. The level of significance should be included when stating the conclusion. Steps 1 to 4 constitute a statement of the problem. Step 5 to 8 give the analysis, leads to a decision, and step 9 provides the conclusion. So here is another problem. The 2019-2020 college-going rate for California high school students indicates that 63% of the students graduating from California high school go on to attend 2-year or 4-year college the year after graduation. The college-going rate for students graduating from high school in Los Angeles, uh, Unified School District was estimated to be 52%. Suppose that the estimate of 52% was based on a representative uh, sample of 500 graduates from which schools in Los Angeles Unified, from high schools in the Los Angeles High School District. So what is the bottom line? In the population, among all California high school graduates, 63% of the students go to attend a college the next year after graduation. For a sample of 500 students, we'll assume simple random sample of 500 students from Los Angeles Unified School District, sample proportion of students who go to attend college within a year after graduation, the same year after graduation from high school is 0.52. Is it reasonable to conclude that the proportion of Los Angeles Unified School District high school graduates who attend the college year after graduation is different from the statewide proportion? So we are saying different from. So it's not greater than or less than. The 9-step hypothesis testing procedure and a significance level of alpha equal to 0.01 is used to answer this question. So what is our null hypothesis? Null hypothesis is P equal to 0.63. What is P? P is the proportion of all Los Angeles Unified School District high school graduates who attend college the year after graduation. It's a population proportion. Null hypothesis P equal to 0.63. What is the alternate? Differs from HAP not equal to 0.63. So the first thing to check, remember our sample size from Los Angeles Unified School District was 500. First thing, we should check that the sample is a simple random sample and n times p0, where p0 is the value in the null hypothesis, is greater than equal to 10, and n times 1 minus p0 is greater equal to 10. We have been given alpha equal to 0.01. Assumption, so then we get the test statistic. Okay. Before we go to statistic, we should make sure the assumptions are valid. One of the assumptions is it should be a simple random sample, which is true because assume this sample is a representative of the entire population of students who graduated high school from Los Angeles Unified School District. The next thing we should check, as I was saying, is n times p0. N is 500. 500 multiplied by the value in the null hypothesis, population proportion, is 0.63. So let's do it. 500 multiplied by 0.63 is 315. That is greater than equal to 10. And also we should do 500 left parenthesis 1 minus 0.63 right parenthesis 500 left parenthesis 1 minus 0.63, hit enter, that is 185, that is also greater than 10. So now we will calculate the test statistic, which is to compare the sample proportion. Remember, the sample proportion is given as 0.52. So we will use this equation. So point on the numerator, we have 0.53, okay, minus, so left parenthesis 0.53, Okay, is it 0.53 or 0.52? Let's make sure. 0.52. So it is 0.52 minus the value in the null hypothesis, which is 0.63, divide right parenthesis of 0.52 minus 0.63 right parenthesis divided by second button and x square. Then we will calculate the standard deviation, assuming the null hypothesis to be true. So it is 0.63 left parenthesis 1 minus 0.63 in the inside the square root in the denominator, that is divided by sample size of 500. So our test statistic value is minus 5.09. Since the test statistic value is in the left tail, we have to calculate the area to the left of minus 5.09, which is the test statistic. And this is a two-tail test. So after we find the area to the left of minus 5.09 under the standard normal curve, we have to multiply that area by 2. So we go second verse, normal CDF number 2. Our lower is negative next to enter, then 1 second comma, which gives me the capital E, 99. So my lower boundary is a very large negative number on the left, which is minus next to enter in the calculator. Then 1, then second comma gives me E, 99. That means minus 1 followed by 99 0. As you can understand, this is a very large negative number on the left from where we start our calculation. And where do we start? We stop at minus 5.03, which was our test statistic. Again, the minus next to enter, and then 5.03. Keep the mu at 0, standard deviation at 1, paste enter and enter. It's a very small value for half p, and then you multiply it by 2 because it's a two-tail test. So what is our p value now? 0.0000000, 6 zeros and then 4, 9. Because it was 4.91 e minus 7, probability value cannot be greater than 1. So definitely it cannot be 4.9. We look for that e minus 7. The minus 7 means the first number 4 is at the 7th place after the decimal. The first 6 places are filled with zeros. That means this p value is very small compared to alpha. Remember, alpha is 0.01. Therefore, p value is much smaller than alpha. Decision is reject 80. We state at alpha equal to 0.01. There is enough evidence to support the alternate that p is not equal to 0.63. Okay. Now I will show you how to do the same test using the calculator. How do we do that? We press stat button. No, before I do that. Okay. So we have to read the problem. Suppose that the college, I'm reading from, let me read from the top. The report indicates that 63% of the students graduating from California high schools go on to attend 2-year or 4-year college the year after graduation. This college gets going rate for students graduating from high schools in Los Angeles Unified School District was estimated to be 52%. Suppose that the estimate sample proportion of 52% was based on a sample of 500 graduates. Remember, sample proportion is equal to number of success, or X, divided by sample size of 500. So if I multiply by 500 on both sides of that equation, my goal is to solve for X, number of success in that 500 sample size. So it will be 500 multiplied by 0.52 or 260. So 260 students out of 500 graduates go on to attend and college within same year of graduation in Los Angeles Unified District. So X number of success is 260. I need that information if I use the calculator. Remember the number of success is 260 out of 500, which gives me the sample proportion of 0.52 from this problem statement. So I do stat button. Highlight test means move the cursor under the stats key to test, TESTS, on the top line. And then scroll down to number 5, one proportion Z test. P0 is the value in the null hypothesis, which is 0.63. My X value, number of success, is 216. My N is the sample size, is 500. My alternate, which is the fourth line, is not equal to P0. Bring the cursor on not equal to P0, which is the first option, and hit enter so that the cursor is flashing on not equal to P0, and go down straight to calculate, put the cursor on calculate, the black rectangle, and hit enter. That will give you the test statistic of minus 5.09 and your p-value, that is 3.50 e minus 7. Again, what does it mean? Point followed by decimal point followed by 6 zeros and 3. Hence, it's a very small compared to level of significance. Alpha is 0.01. P is less than alpha. P value is less than alpha. Decision, reject 80. Conclusion, at alpha equal to 0.01. There is not enough evidence or there is enough evidence to support the alternate. Since P is less than alpha, P is very small compared to alpha, therefore we reject H0. The rule of thumb is smaller the value of P, the stronger is the evidence against H0, which is true in this case. We reject the H0 and our conclusion is at alpha equal to 0.01, there is enough evidence to support the alternate, which is P not equal to 0.63. So point to note, if you want to use the calculator, we need to know the sample, not only the sample proportion, but the number of success or X in the sample out of a sample size of N, which in this case was 500. So the number of success is obtained by multiplying the sample proportion of success with the sample number. We need that information, value of X, to substitute or plug it in the calculator. I will stop here today. If you have any question or comment, you can always write me a small note. I'll get back to you as soon as possible. Definitely, I will answer my question. If you like this video, please give me a thumbs up. I really appreciate that. That motivates me to produce more videos. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And also, please do not forget to watch me tomorrow when I'll be back with another interesting video. Also, please click on the bell button because that will notify you every time I upload a new video. Thanks for watching. Take care. Have a nice day. See you.